Hi students. Now we are going to discuss about coordinate geometry. This another name of the coordinate geometry is analytical geometry. Analytical geometry. In our previous video, we discussed about what is coordinate geometry, what is a Cartesian plane, what is a origin, what is the location of the point, and abscissa, ordinate. These are we discussed in the previous video. So now we are going to discuss now. So if you take any 2 points on the Cartesian plane, what is the distance between these 2 points? What is the distance between these 2 points? How to calculate? Actually, finding the distance is a geometry. Finding the distance by using scale or by using tape or by using any measurement tool. So we can find the distance between any 2 points. But without actually measuring the distance, so we have to write a formula to find the distance between any 2 points in the Cartesian plane. That's the reason why. So this is not exactly measuring like this. This is called analytical geometry. Analytical geometry. So one can analyze. So what is the distance between these 2 points? These 2 points. Let me consider now how to find the distance. Okay. So distance between, first one, distance between any 2 points on the coordinate plane. See now. So coordinate plane, we know that what horizontal reference line and vertical reference line we can consider. This is vertical reference line. So this is x-axis and this is y-axis. So you take this is origin point 0, this is y dash and this is x dash. So now locate any point A. Locate any point A. So this is A point. This is A point. So any point, suppose one point we are going to consider on x-axis is like A, x comma y. If it is 1 point, so I am going to consider 2 more points or 3 more points, like infinite points we can consider on the xy plane. So that's the reason why. So A, so I am taken as general form of the point. We can take it as x1, y1. This is x1, y1. Let A, x1, y1 is a point and B, x2, y2. For our better understanding, I am going to consider both the points on first quadrant 1. So this is quadrant 1. First quadrant I am going to consider both the points now. So here A is x1, y1 and B is x2, y2 we are going to consider. So A is x1, y1, the point. Next, so this point we are going to consider here. B is x2, y2. This is the point now. So now we are going to find the distance between A and B. This is, we are going to find the distance between A and B. A, x1, y1 and B, x2, y2. We are going to consider on a Cartesian plane in the first quadrant. Now how to find the distance between A and B without actually measuring by using scale. If you use a scale or a tape on this particular plane, so that is called simple geometry. So now we are using this geometrical problems on the coordinate plane. That's why it is called coordinate geometry. So now this coordinates, A coordinates, x coordinates and y coordinates, x coordinates, y coordinates. So now where it is exactly locating, we are going to draw a perpendicular line. That is called normal. So why we are drawing a perpendicular line here is where it is exactly locating on the xy plane. So A, x1, y1. This is called x1 point. This is called x1. This is called x1. This is x1. So if you draw, this is a perpendicular line. This is x2 line. So in the same way, if you draw here, this is y1. If you draw here, this is y2 line. This is y2 line. Now, for our better understanding, we are going to consider a perpendicular line here. This is a perpendicular line. So it meets at a C point. Meets at a C point. Now, what is the distance between these two distance? So from here to here, it is x1 distance. From here to here, this is x2 distance. Now, from x2 distance, we are going to subtract x1 distance. Remaining points we can consider. This is, let me consider this point is M normal and this is N normal. Okay, so OM distance is x1 and ON distance is x2. ON distance. Now, what is the distance between these two? This is called x2 minus x1. x2 minus x1. This is the distance between x2 minus x1. From x2 and x1 we are going to subtract. Then what is the MN distance? We can calculate. This is x2 minus x1. Now, in the same way, so what is the distance between these 2 points? These 2 points distance is y1. So we can consider it as P, and this point you can consider as Q. So what is distance between these two? Distance between these two is so this is y2. So y2 distance, this is y1 distance on x y2. So totally we are going to find the PQ distance. PQ distance is nothing but y2 minus y1. So this is y2 minus y1. So this is nothing but parallel lines. This is y2 minus y1. y2 minus y1. So this is x2 minus x1. Now in the same way, this is also x2 minus x1. This is AC distance and this is BC distance. We can calculate it. AC distance and BC distance. Now, if you observe this one, on XY plane, triangle, consider the triangle, ABC, where C is 90 degrees because perpendicular line. So because perpendicular line C is 90 degrees. So if you consider ABC triangle, if C is 90 degrees, so this is called right angle triangle. If you know that the famous theorem, Pythagoras theorem based on the right angle triangle, the square of the hypotenuse equals to sum of the squares of other two sides, legs, other two sides. This is AC is one leg and BC is one leg. AC is another one side and BC is another side. The side which is exactly opposite to the 90 degrees is called hypotenuse. Hypotenuse. The square on the hypotenuse is equals to AB here. So hypotenuse. The square from the Pythagoras theorem. From the Pythagoras theorem. The square on the hypotenuse AB square is equals to the square on the AC square plus BC square. AC square plus BC square. Now AB square is equals to, what about AC? AC length is equals to x2 minus x1 whole square plus BC square is nothing but what? So y2 minus y1 whole square. BC y2 minus y1 whole square. That is AB square is equals to x2 minus x1 whole square plus y2 minus y1 whole square. By removing the square, we can consider it as square root. Then AB is equals to square root of x2 minus x1 whole square plus y2 minus y1 whole square. This is called distance formula. AB distance formula. So distance between any 2 points A and B on the coordinate plane is called x2 minus x1 whole square plus y2 minus y1 whole square. Very important formula. Very important formula. Okay. Now some special cases how to find the distance between any 2 points. Now we are going to observe this one. Now a point, let me consider. So point on distance between any 2 points one point is on the origin, one point is origin, and other point is any point, That means distance between any point from the origin. So distance between any point from the origin. This is O, and you can take it as A, x comma y. So what is the distance between these 2 points? Distance between OA distance, how to calculate now? So let me consider OA. So OA distance. So let first consider this O is 0, 0 and A is x, y. The first point here x1, y1. This is x2, y2. So this is known points x1, y1 and x2, y2. In the place of x2, what is the value x we can consider? This is x2 minus, in the place of x1, 0, that is x minus 0 whole square, plus, in the place of y2, this is y, in the place of y1, this is 0, it becomes. Now, what is the distance between x2 minus 0, x minus 0 is x square, plus y minus 0 is y square, that is OA distance is root of x square plus y square. So, we need not to calculate always origin as 0, 0 and any point as x, y. So if you want to find the distance between origin, distance from origin, any point from origin, distance between any point from origin is nothing but we can directly say root of x square plus y square, root of x square plus y square. This point also, this line also we have to remember that this formula. This formula also we have to remember. Like that, we have some more interesting distances formulas. We can observe that now. Some more interesting formulas we can consider. So let us see. So if any 2 points on x-axis, how to find the distance? X-axis means the first point is x1, 0. The second point is x2, 0. Isn't it? So x-axis, the points on x-axis, y is equal to 0. So if you take y is equal to 0, so simply we can say that means distance between the points, distance between the two points on x-axis is simply we can say it as a modulus of x2 minus x1, modulus of x2 minus x1, or modulus of x1 minus x2 also. In the distance formula also, so we can write it as x2 minus x1 whole square plus y2 minus y1 whole square. So it can be also written as x1 minus x2 whole square plus y1 minus y2 whole square, because square represents positive value. So difference, the square means if you get difference negative, the square becomes positive. That means every distance is positive value only. So in square root also we must consider the distance as positive, because so distance means that is existing quantity. So existing quantity is never negative. So that's the reason why. So distance is always positive. So that's the reason why we are going to consider modulus function. Modulus means, so whatever the value we should consider inside the modulus, so we are going to consider that as positive value. Whatever the value we are obtaining inside the modulus, but we should consider that as positive value. That's the reason why we are keeping modulus here. Now, because distance never negative. Then coming to y-axis. So if you test y-axis, it is modulus of y2 minus y1. Not only x-axis and y-axis. Suppose if any points which is parallel to x-axis, if any 2 points parallel to x-axis, this is, you can take x1 comma, parallel to x-axis is nothing but parallel to x-axis, y is constant, x1 comma k. So this is x2 comma k parallel to x-axis. That means distance between any 2 points which are lies on parallel to x-axis Parallel to x-axis also same formula, modulus of x2 minus x1, because k minus k is 0. K minus k is 0. Now, in the same way, we can consider, so distance between any two points which are parallel to y-axis. Parallel to y-axis is nothing but x is equals to k comma y1, and this is k comma y2. Now this is the point. So y2 minus y1, y2 minus y1. Now we are going to find, so 5 formulas to find the distance. So now, sorry, 6 formulas we find. First formula is general formula, modulus of, so this general formula is root of x2 minus x1 whole square plus y2 minus y1 whole square. One formula. So between any two points we can consider this is. Next, origin to any point, this is x square plus y square, and if you consider any two points on x-axis, then modulus of x2 minus x1, or if you consider any two points on y-axis is modulus of y2 minus y1, or if you consider any two points on the parallel to x-axis is also x2 minus x1 modulus, and parallel to y-axis is also y2 minus y1 modulus. So we are going to find, so first we can observe how to find the distance between any two points first. So one example we can see. Find the distance between A 1, 2, B 3, 4. So now A 1, 2. Let me consider A point as x1 y1, B point as x2 y2. So what is the distance between this is AB distance is equal to root of x2 minus x1 whole square, that is x2 minus x1 whole square plus y2 minus y1 whole square. Distance between any two points on coordinate plane. So now we are going to consider the root x2 in the sense 3 minus x1 in the sense 1, that is 3 minus 1 whole square plus y2 in the sense that is 4, and y1 is nothing but 2, that is 4 minus 2 whole square. So now we can consider 3 minus 1 2 square plus this is also 2 square. Now this can be written as 4 plus 4. You can take it as root 8. Root 8 can be written as root 8 units. Root 8 can be written as, so 8 can be written as 4 into 2, that is 2 root 2 units. 2 root 2 units. The distance between any two points A and B is 2 root 2 units. Now, so if you consider simply the 2 points like this, suppose this is 0 and this is also 0. So if you observe that 1, 0 and 3, 0, 2 points. So 1, 0, 3, 0. Those 2 points we can, by looking those 2 points, we can find the distance. We can estimate the distance because both y coordinates is 0. Whenever the y coordinates is 0, these 2 points lies on x-axis. Whenever these 2 points are lies on x-axis, we have the formula directly. So modulus of x2 minus x1, that is 3 minus 1 modulus, that is 2 modulus, answer is 2 units. So very simple question. But no need to apply root of x2 minus x1 whole square plus y2 minus y1 whole square in all the cases. So if you observe very clearly, so that is in our coordinate geometry, answer is very simple. Whenever you observe the question carefully, so answer is, it lies inside the question only. So that our observation is very important in here. Let me consider now. So one more point. So this is those 2 points we have to consider. So first point is 0, 3. This is 0, 7. So what is the distance? Now we are going to observe. So both x values is zeros. Whenever both x values is 0, then obviously we can say 7 minus 3, that is 4. 4 is answer now. Very simple formula. 4 is answer. No need to apply this formula. Then, so here modulus of y2 minus y1, that is equals to 7 minus 3. So that is 4 answer. That is 4 answer now. So you are going to consider now. So two more points you have to consider. 2 more points. Let me consider now. So 2 more points. This is 3 comma 4 and this is a minus 3 comma 4. Minus 3 comma 4. So here, so 2 different points. Is it different point? No, this is not different points. Let me consider. See here. Very interesting point here. Consider 3 comma 4 and minus 3 comma 4. So if you observe that carefully, here also 4, here also 4. So both y coordinates are 4 and 4. So whenever both y coordinates are 4, both y coordinates are same, that line is parallel to x-axis. If any line is parallel to x-axis, what is the distance formula? Now distance formula is equals to AB is equals to modulus of y is constant. That means no need to consider y. Y is constant. The difference is 0. No need to constant. Now we can consider x2 minus x1. x2 minus x1. This is x2 value minus 3. Minus x1 value is 3. So you can consider this is minus 6. Even though it is negative, we should consider as positive because it is modulo function. So modulus says that only magnitude we are going to consider, not sign. That is called modulus. Modulus means, so consider only magnitude without sign. Without sign we have to consider. That's the reason why this 6 units. Oh, understand. This is very simple concepts. So now, like that, you can prepare your own questions and practice this distance. So by using distance, so one can estimate what are the application of distance. How the distance formula. So distance formula is useful to identify the properties of some quadrilaterals and triangles, so etc. we are going to discuss in next videos. Thank you students. Thank you. So if you have any doubts, please note all these points in your particular notebook and practice well. So very important chapter. This is coordinate geometry. Thank you.